Hope it works. So, hello everyone, and thank you for having me here. So, my topic is Project Jiachen, and my name is Wei Wu. First of all, let me introduce myself. I'm the founder and director of the PLC Lab. This is my day job, and I have many titles and contributions on the free and software system, and especially RISC-V. So the most relevant title here is I'm the manager of the project Jiachen. I also the organizer of the RISC-V Summit in China, also serve as the TSC member of the RISC-V International and many other open source projects. So the PLC lab is very famous in China. It basically provides open source public goods for the RISC-V system ecosystem, and we have collaborations with many open source communities, especially with the artist thread. We will include one or two slides to illustrate how we collaborate with the artist thread community. And before we introduce the project Jiachen, we have to introduce why RISC-V. And before we talk about the RISC-V, we need to give three basic observations. This is a big picture of how the information system are the past and the future. So the first is that Moore's law has its physical limits and it's almost dead, but there's no limit to the demand for computing power, especially in the big model area, so we call it the AI area. The second is that the complexity of a software system grows very fast. It's more than linearly. And the second is less known is the number of developers who are capable of managing the complexity of software is limited. So it's very important observation. We have a lot of conclusions and inference. So first, let me reference an annual report from the Synopsys. It's about open source security and the risk analysis, but we want to emphasize that it in the first page it talks that the authors analyzed more than 1,000 commercial softwares and found more than 96% of them used open source software, and the total amount is area amount is more than 70%. So basically, I draw a picture to illustrate how important what's the closed source code and the open source code was like. So in nowadays, especially after 2000 years, so only if you a new company you want to start a project, the only way to survive is leverage the open source software. So we have some very obvious conclusion in this slide. So software is the word and the open source is the software. So we have to use the open source and contribute back to the open source as the whole community. And there's no any company or sovereign that can independently maintain all the software stacks. So that's why we embrace artist thread as an open source community, because it works, and it works only in an open source way. So we have more conclusions deducted from the basic observations. So why is that DSA will be everywhere? Because that the Moore's law is that we have to devise and innovate in the architecture and the microarchitecture way, but not the way we how we produce the chips. So there will be inevitably many instruction sets. Actually, it did, but because that open source software is everything, and the number of developers who can manage the complexity is limited. So only a few open source communities can survive in every field, only one or two. And in these survive communities, only a few instruction sets will be maintained, because that if in many softwares nowadays, there are compilers, very sophisticated and advanced compilers in the softwares. And the compilers deals with instruction sets. It needs a lot of developers to maintain it correct and optimized. So only a few instructions will be maintained. So and the RISC-V, we now have seen that it's a lucky one, is a winner. So almost every aspects and fields in the open source in the computer industry, there has an open standard. And now RISC-V fills a gap of ISA. So we may ask why. I conclude a few reasons. First is the timing. So it was created back in the 2010. So just that the DSA is booming and almost all innovators needs a new instruction set, and they has a good enough design. So the innovators will communicate with each other and use the good design. So it's a modular design. You can use it as the most smallest MCU to the largest HPC. So it's modular. So you can just add the things you want, add the instructions you want, and drop the things you don't need. And it's a very and a very good business model. So now when you choose RISC-V, you can first choose the instruction set and try to choose your supplier or provider among hundreds of providers. So it's efficiently avoiding vendor lock. And it's an open standard. So the creator team in the Berkeley University, they donate the design to the open area, and they founded a RISC-V International to maintain as the open standards. So and the RISC-V International is very looks very emphasis on the all software system, and starting from the 2020, so all the IVI said this now is a software oriented. All the most important thing is that we need to run software on RISC-V, all software on RISC-V, and the last but the most important is that it's an open standard. So finally, maybe for the first time in the history, the students, especially undergraduates, they can design their chip. They can design their chip as a RISC-V chip and open source it, and you can even use it right after your graduation as an open source project. So let me explain why the last. So before we have open source projects, open source instruction sets, the developers and the innovators can only open source and communicate with their using their softwares among the ISA. So if you have a hardware design, you need to choose the ISA. If you choose the ISA, it's not RISC-V. You may have some license issues and copyright issues. When you put it online, you will you'll get trouble if you're not using open standard. And so after RISC-V get very popular, so a lot of hardware designers and they can open source. They can open source and communicate their hardware designs. So basically, we now maybe for the first time we can co-develop our software and hardware in all the open source way. That's why the RISC-V got very popular. So that's some predictions. Back in 2 years ago, in 2022, we now have a 10 billion RISC-V products can get delivered and produced and delivered, and more than 80 billions will predict by the end of the next year. So it's a very huge number. And why we choose RISC-V? Once you choose RISC-V, you can, if you want to design RISC-V IP, and you want to design a CPU IP, and you choose RISC-V as an instruction set, you will immediately have all the software tools you need to debug your IP, and you have some open source SoC designs to put your IP in. So you can even get some open source EDA to get your designs tested and tape out. And after your chip gets tape out, or get into silicon, or in the simulators, you can run a lot of softwares. Almost now, especially the internet related and the database related softwares now the open source softwares. So they're very mature, and they already support RISC-V in a very good shape. So, but after I talk about a lot of benefits and how we delivered billions of RISC-V in the recent years, but we think very barely see that RISC-V devices in hand. We didn't see that RISC-V laptops, the desktops, or the RISC-V smartphones. So is that the RISC-V are embedded in yet? So before 2022, the answer might be yes, but since last year, the answer is no, because that we now have a very powerful RISC-V chips and very efficient, power efficient chips that we can run Android on it. So basically, there's a SG 2042. So it produced in roughly 30 months ago. 30 months ago, and now we can use it to build the PC and servers, or even we have a 1,000 RISC-V cores in one rack. So that's a very amazing thing. And last year, in the RISC-V Summit China, so a company called SoftGo, they just demonstrated a real rack with 1,022 RISC-V cores in their booth. So it's very impressive. And the other side is that smartphones and the tablets. So now Google had announced they will support RISC-V roughly 1 year ago, and the things goes very smoothly. A few devices now can run Android. So the tablet that can call the phone. They also demonstrated last year in the RISC-V Summit North America. And OpenGDK, we get the RISC-V support even earlier. 2 years ago, they get official support, and now, so a lot of the JDK 17, 11, and even the JDK 8 get backporting. So the JDK is used very heavily on many cloud companies. They will use OpenJDK to run their business. So the support, the upstream support for the RISC-V is a big event in 2 years ago. So, and these days, including Artist Thread, we can see that almost all popular Linux distributors now support or experimentally support RISC-V, and the Linux desktop is almost there. And standing this time, we now see at least 4 RISC-V laptops from different vendors. You can you can buy it online, and after you buy it, you can try all the Linux systems and other systems at hand. And for the language and the runtime, basically every language runtime now supports RISC-V. We now still have only 1 or 2 things to need to. Still the porting work is not still not done yet. So one is the Mono or the .NET runtime. We now call for volunteers to porting and do some optimization on it. So there's some examples. So almost all the softwares are running on popular Linux distributions now get ported to RISC-V, including the Firefox, Chromium, and the Thunderbird. So we now even have the LibreOffice and the multiplayer. So you can basically, if you have a Pioneer box with the Power 64 RISC-V cores, you can run all the softwares you like. But especially they are open source. For the commercial non-open source softwares, we're still in a very early stage. And back in 2 years since 2023, now we have a new observations. So we see the users of RISC-V laptops and the desktops and SBCs, the users are from computer engineers and system developers to the application developers. So that's a big amount change. So they are estimated they are less than 10,000 10,000 or hundred of thousand developers who are doing compilers and the operating system in the world, but they are not. They are 19 millions of softwares. They write codes for the application use or the middleware. So basically, we will see the next 1 million RISC-V software developers for the application. They will try to compile and run their softwares on the RISC-V platform. Some are trying now, and we believe that before the 2025, we will see 1 million RISC-V software developers. So to deal with and with the same vision, so a lot of companies they found in Europe, they found the RISE Foundation. So it was formally announced in June 2023, and right 3 months later in China. So the RISC-V ecosystem, the RVEI, get established in the late August last year. So you can see that's very active development and collaborations in both in Europe, North America, and in China. So let's back to the artist thread. So we see the last few years the artist thread is a pioneer. You can see the pioneer in China on the RISC-V platforms. So Artist-Thread had already supported almost all the small or MCU level RISC-V cores. You can see the full list on the right side. And yeah, sorry, I do not. And I try to get all the names translate into English, but failed. So there's too many. There are too many companies. They are design and they're tape out and they're producing the RISC-V chips and IPs. So more than hundreds of companies now they use and they sell RISC-V related products. What's amazing thing is that we see that in the RISC-V community, almost all the RISC-V cores they have some support for artist thread, and most of them get upstreamed or in process of upstreaming. So we have Artist Smart in these days. Artist Smart, they are already a group of contributors. They try to port Artist Smart on the new RISC-V platform, and we now glad to see that the Artist Smart can run smoothly on the T-Head platform. So we have tested a few of them. It was very good. And we would like to thank the community, especially the Isong Chen from the Artist Thread Committee for providing and collecting and providing this useful information. We appreciate that. So back into the PLC lab I found, I'm also the director of the lab. So we have a lot collaborations with Artist Thread. One is that we have a very good collaboration relationships since back into 5 years ago when I started the PLC lab. So and as Artist Thread is used as a verification environment by default in the RISC-V MCU and IoT field in PLC lab, and we PLC lab and Artist Thread has jointly recruited and trained more than 30 interns to contribute source code in the Artist Thread community, and some of them becomes mentor of the community. We are very proud of that. So just for information, if you're interested in getting some internships, you can try to visit the link. We have a famous repo called We Love Interns. Just on the GitHub, when you search these terms, you will get the repo you want. And now we have a new position for our interns is that we now collaborate with the Xuantie team. So we now have a called a new 32-bit innovations, and we want to try to get RT-Thread and or RT-Smart run on the new RISC-V, the latest RISC-V devices using the new RV64 ILP32 combination. So I'm very pleased to announce that the RT-Thread community has joined the Jiachen project 3 months ago. So now finally we get to the project Jiachen. So first is why start a new project. So basically we now all agree or think that predicts that open source software community of RISC-V is inevitable. Almost every open source software communities, they say that they already supported RISC-V, or they are trying to porting their software to software. So it's inevitable. But the porting and the optimization for the commercial software is still in a very early stage. So that's the reason I do some surveys that due to the high openness of RISC-V. So it's if RISC-V chip companies, they can put money to do some porting work for the commercial softwares, they will get nothing but their chip companies can directly reuse it without paying the porting cost. That's most the case. So I created first mover disadvantage, not advantage, but disadvantage. So I am the RISC-V ambassador. I'm the promoter of the RISC-V in China and worldwide. So I have some responsibilities. So I keep thinking in the past 2 years. So as a promoter of the RISC-V ecosystem, what can I do? So what can I do is that I finally, in 3 months ago, I started a grant plan called the Project Jiachen. So this is Asian Chinese Asian Chinese characters in this picture. So you can just treat it as a picture or the art design. So why 12 years? So because that 12 years is just a loop of the time in the Asian Chinese calendars. So we keep the vision that RISC-V is the future. So I think that we all more than less agree that, and all areas involving ISA will be covered by RISC-V, and open standards as a ISA and open source software. They are good match. They will become the cornerstone for the future business, and they will finally achieve to the commercial perspective within 12 years. Software companies and the commercial softwares, we can connect together and to port optimizes and optimize and deploy more than 1,000 commercial softwares. And second is we want to have some solutions to demonstrate and to reuse and in an open source way in all the industries, especially in the AI acceleration, storage, robotics, edge computing, and a lot of other important areas. So the last and the important, we want to identify and connect to create an environment so we can have more than 10,000 talents in RISC-V chip design, software development, and community building. So that's a very ambitious goal. So, but the project Jiachen is organized in a very simple way. So it's a manifesto style. Every company that shares a vision is welcome to join. And you just write an email to me. We will talk 1 or 2 times. And if you agree the manifesto, so you can join. And all members are equal. There's no steering members, no general members, or nothing. So all members are equal, and members can invite each other, and they can start a new project, and the other members, they can join freely if they wish, and you can contribute. The more you contribute, the more important you are in the project. So the governance is very simple. So you may see that it's not the same as the other foundation or communities. So it's no donations, no financial entity, and you do not need some to fees to get into as a member. So only there's no board, no bureaucracy. You only one manager is me. So I have a day job, so I do this all in a volunteer way. So the portfolio is very simple. We just has a website, and the website is hosted on the GitHub pages. We have a GitHub repo and WeChat account. That's all we have. And all the projects, now we have several projects we will announce in a few months. So some members had already started some new projects among the project. So first is that members don't get paid for it. They don't get, but they can donate money or give money to the other members or the volunteers. So who can deliver the projects or the key results the member want. So also they can directly negotiate to other members to join and provide a financial support or human resources. So I will introduce that the PLC Lab is giving some human resource support into many open source projects and the special commercial projects. And the manager me. I will connect and summarize member needs and to give a list of open source projects or demands in a few months. So, and the PLC lab I joined will provide engineers to help improve especially the open source software system to the RISC-V community. So there are three major funding models. Due to the time limit, I will go a little faster. So one is a single dominate player. So this is a very simple. If a field is dominated by one company, so then just the company they can give some money to others and to let the other players to get the software ported. And the second is the most common case. So we need to compile the majority of the players. It means that a lot of negotiations involved, and the project Jiachen manager, me, will play a negotiator, will talk with each companies and try to get a combination. They will start a task force or the small project and put some money in one place, and we will recruit or invite some companies or teams to get the things done. And the last is what's very common in China and in America. So we have some national support financial funding. So this funding is used for all the humanity, all the companies in the China or in America. So we all see that the governments now spend money to the chip area, and RISC-V companies get very heavy invested in mainland China, which is a very good thing we think. And also PLC Lab gets some national fundings, so that's why we can do open source software and recruit many students. So this is a basic list how the PLC lab is good at. So we were very familiar about the compilers and the virtual machines and the simulators. And we now working on dynamic real and RUI SDK, which we think that we can highlight worth to highlight. So if you are doing some profiling for improving those CPU designs, the dynamic real is a very good software that you can try. It has a low overhead, and now our RISC-V support is mostly going upstream, and RISC-DK is just the latest program the PLC lab is working on. It's a 3-year meta project. It's all open source. You just go to the GitHub and search the word. You can get a lot of repos you may interested. So that's all I have today, and welcome to join the Jiachen project. So last thing is that we now have this year, we also have a RISC-V Summit China, and the CFP will end by the 2000 this month, to 22nd this month. So I hope to see you in Hangzhou in this August. And all previous videos are online. You can just go to the link. It's all on the Bilibili. And thank you for having me here, and welcome to join the RISC-V ecosystem, especially the artist thread community.
Thank you for the talk. There's a lot of interest in this project. What if I'm bored or not a Chinese citizen? How can I engage with the project?
Yeah, so actually, so we are welcome all the developers and the users, RISC-V users to get involved. So basically, you can just you can just search the link I have in the previous pages and just try to start it. And basically, we will have some new announcement to accept the individual developers and the users to get into the contributions before the end of the August. So we are still in the very early stage to get all the organizations, communities, and individual developers in a good organized shape. So just please to go to the website and the GitHub organizations and to watch the repo. We will do all the things in the open source way. And after that time, if you get the announcement and the notifications, you can just send a pull request to the repo in the GitHub organization. And when the repo get merged, you can treat yourself as the member of the project.
Are also the internships open for internationals?
Yes, all worldwide.
That's nice. You talked a little bit about high performance RISC-V cores. On the other end of the spectrum for IoT applications, do you see there large demand or development requirement for low power, high efficiency cores?
Yes, so the goal based here is the all area. So we can treat that in the interface all area. And now we think that the most initial part and the most hard thing is the servers and HPC and the high performance chips. So we have some emphasis on it. And for the IoT and the edge computing, we think that RISC-V is in a very good in a good state, and we will still have a lot of involvement, and still many contributors and companies are already working on it. So basically, you can see that now more than 20 companies have joined the project Jiachen, and half of them are there working on the IoT system, including RISC-V community, including the artist thread community.
Is there a chip you would recommend in particular if somebody is interested on new to RISC-V?
Yeah, sorry, I didn't catch the question.
If somebody is new to RISC-V and wants to get into the topic, is there an MCU which you would recommend for this?
Yeah, so yeah, sorry, I'm not sure that I heard the question correctly. So for the further questions, feel free to write to the email. So I'm good at the writing email, but I'm not at the English.
I
And
think the question was in this regard.
my AI is not good at yes.
I think the question was meant like this: a chip which has good documentation and is easy to develop for.
Yeah. Yeah. So can you please the last question in the chat window so I can see it? Yeah, sorry. So my network is not stable, so I didn't catch the keyword in the last question. Yeah, hello?
Hello?
Okay, so I think my time is limited. Yeah, so I see the question is that which RISC-V MCU can you suggest to start with? There's a lot of MCU you can start with. So the WCHSS and all the things you can buy on the internet, you can just use it. And if you have any questions, you can go to GitHub and search the RUI SDK and just put the issues. We will have a lot of volunteers to answer the question and give technical support.